Welcome to your Lesson 6 podcast involving solving trigonometric equations. Now, today, we're going to kind of go back to something we started last chapter, which was solving equations like these. Now, what we actually talked about last chapter is these equations technically have infinitely many solutions. But specifically last chapter, we talked about what were the solutions to these equations on one rotation around my unit circle, or on one cycle of sine or cosine. Okay, so what we're going to do for these problems is first we're going to find those two solutions on one cycle of sine or one cycle of cosine. And then we're going to talk about how do you get more solutions and how do we write a general solution that would express all of those infinitely many that we mentioned. Okay, so what we're going to do is for this function, um, we can use inverse sine to get one of our solutions, just like we did last chapter. So theta equals inverse sine of 0.8. And your calculator will give you this solution of 0.927. Okay? Now, the only thing, as we know, this equation is going to have two solutions on one cycle of sine or on one rotation around the unit circle. So our calculator doesn't directly give us those. So what we have to do is we have to find them on our own. Now again, I'm in radians here because notice the interval for theta is in radians. So I'm going to make sure my calculator's in radians as I do this. Okay. Now, what I like to do is I like to mark off this radian measure on my unit circle, and it's a little less than 1 radian, which is a little less than 60 degrees, so it's going to be somewhere up here. Now, what you have to think to yourself is where on the unit circle do I have an angle that has the exact same sine value of 0.8? Okay, and that value is going to be flipped over, or sorry, it's going to be the same angle flipped over the y-axis, sorry, reflected over the y-axis. And I need this angle measurement right here. Okay, so now you got to think geometrically and think about what kind of geometry would give you that angle measurement. And for our problem, it would be pi, which is 180, which is the half circle, minus my original angle, because this angle here and this angle here are the exact same size. So I'm going to take pi minus 0.927. Okay, now that gives me my second solution on one cycle around the unit circle, which is 2.2143. Okay, so now I have my two answers between 0 and 2 pi. Now, again, what we said is there's technically infinitely many solutions to this problem. Okay, because I can rotate around the unit circle as many times as I want. And if I keep rotating around this unit circle, I'm going to keep hitting these 2 points. Okay, so how can you get more solutions? And the answer is to add on the period. Okay, so what I'm going to do is if I wanted to find more solutions, I could just add 2 pi onto either one of these. Okay, so if I'm going to write an expression that represents the solutions, and actually in this case I'm going to use expressions, I'm going to say, okay, theta can equal 0.927. But again, to get more solutions, I can add on 2 pi. So what I'm going to write is 2 pi plus 2 pi n. And I'm going to do the same thing for 2.2143 plus 2 pi n, where n is an integer. Now again, what this implies is that I can add on 2 pi times 1, 2, 3, 4, 5. So I can add on 2 pi as many times as I want, and I'll keep getting solutions to my original equation. Okay? Now this next one, pretty much the same thing, but I'm dealing with cosine. Okay, so this time, notice I'm using an x variable, and my x interval is in degrees. Okay, so I'm going to use inverse cosine. But again, this time, make sure your mode is in degrees in your calculator. Okay, so what you're going to get on your calculator, you're going to get 66.422 degrees. Okay, now again, that is one of the answers on one cycle around the unit circle. Let me do this here to separate this a little bit. So what I'm going to do is I'm going to pull out my unit circle. I'm going to draw in an angle measurement of 66.42, which would be about here. And then I have to think to myself, where else on the unit circle am I going to have a cosine value that's the same? So again, that's going to be the x value of this point, which is going to be down here. Okay, so again, this here is 66.422. So what is this angle measurement going around? Well, what you should recognize is this small angle is going to be the congruent to that small angle down there. So again, think geometrically. The whole unit circle is 360 degrees. Okay, subtract off that 66.422 degree measurement. Okay, and that'll give us our second answer of 293.578 degrees. So these two answers are the two solutions between 0 and 360. But again, I want an expression that represents all possible solutions to this. Okay, so what I'm going to do is I'm going to say, okay, x can equal 66.422, but instead of adding on 2 pi, if I'm working in degrees, to get more solutions, I can add on 360. So I'm going to add on 360n. And I'm going to take the 293.578 and add on 360n to get more solutions to this thing. And again, this is where n is an integer, like that. Last one is tangent. Okay, starts off the exact same way. Okay, so I'm going to go theta equals inverse tangent of 2.31. Okay, again, inverse tangent is a function, so it's only going to give me one of the possible solutions to this. And again, because my variable was theta, my interval was from 0 to 2 pi, so I'm going to work in radians. Okay, this time my calculator gives me 1.162. Next, I'm going to go to my unit circle. This is going to be a little over 1 radian, but again, it's still going to be in the first quadrant. So my first answer is there. Now again, what you have to think to yourself is what other angle on the unit circle is going to have the same tangent value? And it's going to be directly opposite. Okay? So if I'm going to find the two answers between 0 and 2 pi, I'm going to take this original answer, 1.162, and because it's exactly half of the circle away, I'm going to add on half the circle in radians, which is pi. So my other answer in this case is going to be 4.304. Okay, these are the two answers between 0 and 2 pi. Okay, now finally, to get my general solution, I'm going to say, okay, theta equals 1.162. Now again, I'm going to add on the period. The thing that's different about tangent is the period on tangent isn't 2 pi, it's pi. So what I'm going to do is I'm going to add on pi n. Okay, now the one thing that's kind of nice about tangent is if you notice my two solutions between 0 and 2 pi are exactly pi apart. So what ends up happening with tangent is you don't need two separate expressions. If I add on pi once, I get 4.304. So if I add on pi once, I'll be at this point on my unit circle. If I add on pi again, I'll be back to the same position, okay, as my first solution. If I add on pi a third time, I'll be back down in the third quadrant at this position, and I'll just keep switching back and forth. So for tangent, you only need one expression. Okay, next. Part 2, solving trig equations that have a different period. Okay, so we're pretty much going to do it the exact same way. We're going to solve the equation by finding the two solutions on one cycle, and then we're going to talk about how do you get more solutions from there. But notice, if you think back to sections 1, 2, and 3, my period, if I put a number in front of my x value, that changes my period. So all of these functions on the left all have different periods from normal. Now, if you take a look at the top two, okay, these are ratios that we should know directly off the unit circle, so we'll be able to do those without a calculator. The last one, 3, is not a tangent ratio you needed to know off the unit circle, so we can use our calculator on that one. Okay, all right, so what I'm going to do here, okay, I'm actually going to kind of break this down into steps. And my steps are going to be the same as the previous slide. Find two solutions, okay, without the change in period. Okay, and then kind of my step 2 is going to be to set those solutions equal to, I'm going to call it the BX. Okay, because again, when we took a look at these equations on back in the previous section, we called that number that I multiplied my x by my b value. So what I'm going to do is I'm going to find my two solutions without the bx first, and then set them both equal to bx. And then we'll talk about how to get more solutions. All right, so what I'm going to do, sine of 2x equals 0.5. So because this is a ratio off your unit circle, I'm going to go straight there. Which values have a sine value of 0.5? And notice it says I'm working in radians here. The angles that have a sine value of 0.5 were here and here. This was pi over 6. This was 5 pi over 6. So because it's a nice ratio, it's pretty easy to come up with those values. Okay, so it'll be pi over 6 and 5 pi over 6. Okay, so step 1's done. I found my two solutions pretty easily. Okay, now next, what I'm going to do is I'm going to set those solutions, both of those solutions, equal to 2x. So I'm going to say 2x equals pi over 6 and 2x equals 5 pi over 6. So my x value is pi over 12 here, and my x value is 5 pi over 12 here. Okay, so what I have, these are my two solutions directly off of the unit circle. So I found those. I found the two answers that are in one cycle. Okay, now what I want is, how do you get additional answers from this? On the previous slide, we always added on 2 pi for sine or cosine, and we added on pi for tangent. Well, these ones are going to be a little different. How do you get additional solutions? Okay, and the answer is, you get additional solutions by adding on the period. So you kind of have to do one more thing. The period is, again, 2 pi over b. So my period in this case is going to be 2 pi over 2, which is pi. And let me give myself a little bit more room here so we're not scrunching everything in. Okay, so these are my two main solutions. And then to get more solutions, add pi. Okay, so what I'm going to do to each one of these, if I want to write this as an expression like we did on the previous examples, I'm going to say x is equal to pi over 12 plus pi n, or x is equal to 5 pi over 12 plus pi n, okay, where n is an integer. Okay, so this would be like an expression for the general solution like we were coming up with on the previous slide. Okay, I'm actually going to pause here and start a new podcast. So we'll see you in just a second.